I am Groot.
T3D Medic and Matt, how are you guys doing? My happy victims. Let's hope the chat stays live today. I've been trying to shrink my little box down to, a smaller, more manageable size that doesn't use so much plastic, and boy, is it giving me heartburn. I'm making it this little size. It's gonna look nice. It's just I keep making little tiny mistakes that are driving me crazy. And I think I literally, after this one, gave me a heartache. So this one I finally got the print sort of right, except I forgot to update the slot on the back for the new profile. And but I finally got the front to print correctly. There's no bubbling. It's properly fused. And now the side is unfused. The only thing I can think of is I must have shifted the slot a little bit so it's not touching the outside properly. Where do you live, 3D Medic? But I figured out that I needed a bottom on this because otherwise when you put the lid on the back, it just falls through. Oops. So now the back has a floor so that when you put the lid in, it stops. It doesn't go anywhere. Cincinnati, okay. Well, you're humid, but you are farther up north. Oh no, Cincinnati. I'm thinking Connecticut. You're Ohio, so you're hot as balls. um, yeah, just air conditioning. That's all you can do. Depending on how old your house is, make sure your circulation is good. You got to get all that hot, humid air back to the input registers on your air conditioner. Because if the air conditioner focuses on one room, then what'll happen? It'll cool that room, and then it'll just turn off because it says, "I'm there. I'm where you set me," and the rest of the rooms are just boiling. So you gotta move that air around. Do you have central air, or do you have like window units? Central. Okay, so make sure you get. I don't know how much you know about HVAC, but you should have return registers. These are usually sometimes they're on the floor, but usually they're on the walls. So you'll have you might have multiple, you might have one in a central location, but there should be on the wall somewhere what looks like an AC register, but it's big and it's on the wall. That's actually your input. So that's where your HVAC unit sucks in the air from the house and draws it into the AC unit, and then it comes out the output registers. Make sure that's clean. If you can access any of your ducting, make sure it's all connected. Make sure nothing made a nest in there. Usually, if something makes a nest, you'll smell it. Especially once you do a seasonal change, you'll smell it moldy. So if you ever have a moldy smell, that probably means something died or something made a nest in one of your registers somewhere. and the air is being drawn through it like a filter. So just make sure your input is clear, and if you take your shirt off and stand in front of the register so you're touching it, you should feel the air being pulled in when the system is running. Feeling input air is a little more difficult than feeling output air. That's why sucking doesn't work as well as blowing. Well, it does work as well. It works the same. You just don't feel it because when you blow air out of something, you get a column of air that does that. But when you suck air in, you get air from all the way around the entire unit. So air comes in from here, and so obviously it's the same amount of air, but instead of being a column of air that's big, it's a dome of air as big as 180 degrees around your register. So suction never quite feels the same as blowing. Hey Jerry. So I think I figured out what the problem is with this. Because I designed that box to be gigantic from the start, and then I shrank it down to this size, and I realized two problems. One, slight errors are magnified when you scale, and also I realized I made my slots 0.02 millimeters, but I'm shrinking the box to 45%. 40% was worse, but 45% gave me that nice, softball size that I want. I realized that by shrinking the box to 45%, I'm shrinking the slots below 0.01 millimeters. Because if the slot is 0.1 millimeters wide, and you shrink it 50%, now it's 0.1 millimeter wide. Shrink it further, and you're going below 0.1. And the slicers don't like details below 0.01 millimeters. So I think portions of the edge of my slots are disappearing. They're being ignored by the slicer because they're too small. So I have to, I got to remake the slots at the 45% scale so that they're still 0.02 millimeter wide. I also got another idea. I don't know how effective it's going to be. It won't be as material efficient, but it might increase structural integrity a little bit. Instead of having a slot, what if I have a actual slot like that? So instead of coming in and out, go in, over, and out. Make it more dramatic. It'd be a little bit more work, but might give me more structural integrity. Especially if I can make that slot three-dimensional. So instead of having it be a square like this, maybe have it be a triangle. So start here, go out this way, come over, and then come back again. And if I can make that point fuse, that might add a three-dimensional hole through the model, especially for the rockets. And that might increase the structural integrity of the rocket with a minimal mass increase. It will increase the mass slightly, but we're talking 5%, 10% tops. So the strength increase might be worth it. So today I'm going to fix the goddamn vase once and for all. See here, I have it scaled for 1 millimeter. I changed the shape of the profile to this kind of shape. I have a slight bevel on the bottom edge here to take care of elephant's foot, and I've changed the shape of the profile in here. This is the original shape, and while this original shape works, this part prints fine, this part doesn't. So no matter what layer height I use, this part prints okay, but this, it prints fine, but as you can see, it's sloppy. It curled. It doesn't lift off the bed. The nanopolymer won't let it, but it still curls a bit just because it's such a short little part, and the layers are so thin, and that's so this angle gets all screwed up. Top prints fine, but the bottom gets all screwed up, and so changing that profile, it still fits, but not correctly. changing that profile shape to this shape just completely eliminates that problem altogether. It just makes the problem go away. So let's bring this into a new workspace. I don't need you, and I don't need you. This is copy, right? Yep, copy. Yeah, why isn't this refreshing? For some reason, the phone just doesn't refresh properly. Did it? Maker bees? Good. So to show you, give you an idea of what I'm talking about with that, let's do an 80 millimeter tube. Let's do a, let's do 70 will be 5 millimeters. So let's do a 60 millimeter core. Yeah, that looks good. Let's see. Do this and this. So that'll be our core tube. Now, easiest thing to do would be to take a basic triangle, uh, 180. Let's go 2 to 1. Oh, come on. I hate this where it doesn't give you the click boxes. It's annoying. Let's do a 10 by 10. Now I want to encourage fusion. So let's make it 12 millimeters. Let's make it 0.02 millimeters. And that should encourage fusion. This is probably below the bed. Yep. There we go. That's not what I want you to do. Stop selecting the other parts. See, look, you keep selecting the other parts. I hate that so much. Really, you want me to bring you out here? Now you're not selecting the other parts. God, that's annoying. We're going to have to extend this a bit. And we're going to have to do this. Let's shrink this all down to make it easier to work with. Okay. Now the idea is this. That is below 0. How'd that get below 0? Okay, that should do it. Nope. We want these to be aligned on center. No, the slice, if you hard code the design properly, the slicer is fine. That's not the problem. Well, if you know the tricks, I'll show you what I'm talking about. For example, one of the tricks is to make absolutely certain that your thin wedge like this here does not go below 0.01 millimeters. So I designed them all to be 0.02. This way I have a little bit of leeway to stretch the part a little bit. And you got to turn off if you're probably using Prusa Slicer, You got to turn off minimum radius. Let me show you what that is. This is where you're going to run into these problems in here. There's one setting you got to change, and it makes life so much easier. Let's see here. Where's that? Is it under advanced? Here, slice gap closing radius. You got to change that to 0. Because if you make really thin cuts in order to retain vase mode, this here is what is going to make those cuts disappear and merge together into a solid object. So change slice gap closing radius to 0, and most of your vase mode, your complex vase mode, like the kind of stuff that I do, most of those problems go away. If you're using Cura, give up. Just stop. You're done. I cannot get Cura to slice any of these models. It just won't work. Something in Cura's automatic corrective algorithm, whatever it uses to attempt to fix the model, breaks every one of my vase mode models. I have yet to figure out a way to do it in Cura, so just give up. You got to use either Simplify 3D or Prusa. But in Prusa, this is the key setting you got to change right here. And then, of course, you got to turn off adaptive extrusion. You got to make sure that you are defining. This is a default profile, so I'll change this all to 0.4. This all has to be 0.4. Every one of these has to be 0.4. You have to make sure it's your nozzle diameter. If you don't change all these to 0.4, what happens is your 0.40 slot is now trying to be extruded at 0.44, and it fails because it says, "Oops, that's smaller than my 0.4," so it merges, and it basically makes the tool path invalid. So it's all these little things you got to find and fix. I don't know how important it is, but G code resolution, I changed that. Here it's 0125. I make it 01, since that's the smallest feature I design anyway. I don't know how important it is. I'm not taking a chance. I just take care of it by doing that. Anything else important? But yeah, you got to make sure you manually set all these. Don't let the slicer decide. I don't know how important this is. Allowing it to reduce the perimeter width to below 85%. I don't think that'll break it. Because you got to remember, when you do vase mode, everything's perimeter. The whole entire model is one perimeter. So perimeter settings can have an impact. So I would probably think that changing 100%, minimum feature size, or just turn off Arachne and use regular. Just turning off Arachne might just eliminate that as a problem. Yeah, so going classic might take care of that. Be careful with layer height. You do not want to use adaptive layer height, because then features of your model that work fine at one layer height might not work. That's all I can think about at the moment. But yeah, that's how you make sure a Prusa slicer behaves. It's like, behave. Rawr. So what I'm doing here is I'm creating a profile that looks like this. Now here's how I take care of this shape out here. This is interesting. So watch this. Let's go to 0.25. Let's come out a little more. I'm coming out a little more because I have to shift it. we do is we take a block like this, and we get the profile like this. So how tall is this? Let's make this 50. Let's make this 50. It's better to manually define all of these before you mess with them, because sometimes Tinkercad just does weird things where it'll just make assumptions you didn't ask it to make. Double check, make sure everything is centered so that you can do your rotation. Now what we do here is we take our object, we duplicate it, we turn it into a cut block, we join it with this block that all overlaps, and now this block has the profile of the tube on the outside. Okay? Now I take this, turn it into a cut tool, and I use this to cut this. Now my triangle has the exact outside profile shape of the object, which means this part here will fuse with the outer skin, which is important. Now what we do is we take this and we have to translate it 2 times our nozzle diameter. Sometimes I go a tiny bit less to encourage fusion. So it's 0.8, so I might go 0.75 to really make sure it fuses. You can wiggle this a little bit. So what we do is you grab this part here and you shift it, hold down the shift key, and you move it sideways. See how I'm fixed on the x-axis, or I'm fixed on the y-axis. If I don't hold down that key, it can move freely. If I hold down that key, it's fixed on the x and y axis. So you hold down the shift key, you move it this way some dramatic amount. Now you know you're moving in the right direction, and now you also know it's negative. So we do negative 0. Let's do 78. Now I have my little gap here that gets me the space to allow the nozzle to propagate through that area. Now I don't have to do not conflict to create a tool path that doesn't break. I don't need to create a master ring because the tube is the largest part of this object. So we're good for that. So we hold down Control D, Shift, select this tube here, and we rotate it. We're going to do, let's do 1 tick. Like that. Now we just hit Control D again. Again, until we get all the way around. Okay? Now, I come back in here, I go vertical, I select just these orange tubes. And then I hold Shift and I select the orange tube. Now I'm deleting all the duplicates. Because each time you duplicated the green piece, you also duplicated the tube. And now I should have 1 single tube left. Okay? Undo. Now what I'm going to do is I'm going to make that tube go away. This was the tool we created. I'm surprised that's still there. Okay, we don't need that. So, oh wait a minute. Oh, I changed it. I didn't delete it. I changed it somehow. Okay, so this, and I hit this instead of this. Hide it. Now, the next thing I'm going to do, I'm going to select this, and I'm going to ungroup it. And I'm going to ungroup it again, and I'm going to take this here, and we're going to stretch this out. Let's go 15. A little bit bigger. Let's go 18. Okay? Now I'm going to take this cut tool and I'm going to re-merge it with the green tool, but not merge it with the red piece. So now I have this sticking out. This connects my inside surface with my outside surface. If you forget to do this, you can't create a valid tool path. There we go. So this is my key pin. These are all internal cuts. This is a cut that is both internal and external. This is what links it all together. Now I select all of this, join it into one piece. Now, this is a complicated part. Okay? What I mean by that is that this is not one single piece. It looks like one single piece, but it's actually made up of, 1, 2, 3, 4, 16 pieces? I think this is 16, but it's more than that because you also have these little slots here. So this is actually like 32 pieces. That's a pretty complicated part. Now we're going to leave it like that in here because it's simple. But if you run into problems with Tinkercad getting too complex, you're starting to generate errors and flaws, what I can do is I can export this as an STL. So I export STL. It's going to be called Fabulous Kirk and Jerry. For some reason, Tinkercad's been taking longer to export my models lately. I don't know why. Like, this should export pretty much instantly. But you see, it's taken a while to do. I'm not sure why. Sometimes it actually gets stuck, and I have to just restart it. So I'll take export again, STL. Let's say you want to restart. Yes. Sometimes it works, sometimes it doesn't. What is it doing? Guess I just have to wait. I know it's merging everything into one manifold part. There it goes. Now we go import, choose file. We choose the file we just exported. And I'll show you why in just a moment. So this part is actually one piece. This part is 32 pieces. And the more pieces you have, the more complicated it gets. So first thing you do is you inspect the part. Make sure there's no glitches or flaws or holes or warts and protrusions. Yep, it looks fine. And what we do is we align these two parts to get this part where it belongs. Then you hold down Shift, you select the part. What that's going to do is that's going to make sure this part stays put. And we're going to align the two parts together. I grab my green part, and I take my green part and I put it out here. So I'm keeping the complicated part in case I need to edit this profile later. But now at least I'm using a simple part for the model. Now, is there actually enough space here to make this turn? Ooh, I don't know if there might not be enough space here to make this turn. There should be. Yeah, we're going straight out. It's 2 times the nozzle diameter. It should be okay. I might need to put a little divot in this triangle to make sure there's enough space for the master key to come out. So now we take this, turn it into a cut, and combine. And there you go. Now we have a 3-dimensional complex phase mode print. You see it comes out here. That connects the inside and the outside. And I'm hoping that the 3-dimensional nature of this shape will increase the strength of the part. Now for maximum strength, I would probably want to have a corrugated surface. So this triangle would actually come all the way out to here. And these two triangles would basically meet right here. And then when I came across this way, it would actually come across and bump, 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 and create some internal corrugations to strengthen the skin. That would greatly strengthen the skin, but would also be incredibly complex to do. I might try it one day just because it'd be fun to do. I could also create indentations on the outside of the skin. So for example, I could do something like so 50, increase the number of sides. Let's make it 5 by 5. Let's overlap this into the model just a little bit. Let's align this way. Now, For this, since this part is outside of the diameter of the center part, I need a master ring. So we drop ourselves a master ring, increase the wall sides and the diameter to be a little bit bigger than the rest of the model. Then we take this part and this part, since they are both symmetrically round, freeze this part in place, align the master ring to that part. Now I have a master ring to rotate. So I'm going to take this part here, Control D, rotate one tick, which is 22.5, rotate it all the way around. Okay. Now I have a whole bunch of master rings, so I'm going to select the master rings, shift, pick one of them, hit delete. Now I only have one. You always got to remember to get rid of your garbage. Now I'm going to select my part, hide it, select everything, unselect the master ring. So now I just have this. Solidify that into one part. Bring everything back. Bring everything back. Now I need this in between these. So 22.5 would be 11.25 degrees. So I take this. This is symmetrically round, so I don't need to use the master ring. And what I do is I take this, select it, 1.25, and now you can see my little divots here sit in the center of the model. Now I, in between the triangles, join there. Now I create a little external detail in the model, so it'll actually look kind of neat, but that'll also increase the strength of the model. So I'm basically adding corrugations, equivalent to a corrugated part, and that'll increase the strength of the part. Now because I did this properly like this, I can scale this in length. So I would have to join this with my threaded parts, but now I can change the length of this. It'd be interesting to print this to see how that comes out. It'd be very interesting to print that and see how that comes out. But yeah, that's a pretty interesting part. Now I could also do the same thing on the inside, but these cuts are close enough together that this inside surface is going to be pretty strong. You don't need to do it. However, if you wanted to add a little bit of interior strength, you could add, you could basically create more of these ribs, but have them only a little bit. You can do the same thing on the outside, but the exterior of the model looks better if you have a feature instead of just a simple rib. The other cool thing is that a design like this would be great for a night flying rocket. Am I not seeing chat? No, it's still there. Okay. The other cool feature is that I could run fairy lights through these slots. So if I did it right, I can run lights through here and light up the model from the inside. But yeah, that should greatly increase the strength of the model. And you don't have to use triangle shapes. You can use other shapes. You just got to make sure that some part of this shape actually touches the outside surface of the model. It doesn't look like it's touching, but remember, this is only 0.78 millimeters thick. So this is going to be split in half. And I think I can show you. 0.38. So if you get down to the proper scale, this will actually be the width of your extrusion on your printer. So as you can see here, it's of course all my controls are out here. There we go. So as you can see, there is just enough space here for your two printer extrusions. This is how thick the plastic, this right here, is how thick your plastic is going to be when you print. So there is just enough space here for both of those to exist. Damn it. Tinkercad does not like working tiny like this. So as you see, that's going to be your outside perimeter, and this is going to be your inside perimeter. So this is going to be the plastic that's creating this triangle, and this is going to be the plastic that's creating your outer wall. As you can see, these are going to touch. So these two will fuse together when it prints, and that's important because you have no structural integrity. This only adds structural integrity if it's connected to both the inside and the outside wall. That connection is what creates the structural integrity. You can even go so far as to put these little bumps on the triangles itself. So a bump here and a bump here would, again, it would add almost no material, but it would increase strength. And it's not really that complicated. You just take this half moon shape here and add it to the side of the triangle. 5 millimeters, not even 3 millimeters, and you create a little bump here and a little bump here. All you'd be doing is modifying the shape, like I did with this here. And all of that will just go toward making the part stronger and stronger. Now, the only problem with adding a feature like this on the outside of the model, if you're making a one-piece model, you're fine. But if you're doing like I'm doing and you have a multi-part model that threads together, these probably aren't going to line up, and that can be a problem. That can be a pretty big problem if those parts don't line up. So this would be better off printing this with like a 400 millimeter printer. So I can make this 400 millimeters tall, and now just print this as one piece. Or a model that you're going to sleeve. So instead of threading it together, there would be a coupler to join these two halves together, so that you can, before you glue it, you can manually line it up and make sure they line up correctly. There's different ways to deal with that. I'm going to make this 200 millimeters tall. Let's do it 100 millimeters tall as a test print. No, I need a 200. 200's better. But yeah, now I'm super curious how this is going to print. Now something else I could do is I could get rid of this key that attaches the this to this, and what I could do is I can put a small little slot right here that just goes in a couple millimeters, as a design feature, and then put my key cut in one of these, and now the key cut disappears. It looks like it's a feature of the model, and so it actually basically goes away. From 12 inches away, you'd have a tough time finding it. That's interesting. I'm gonna print that just to see how that prints. But yeah, that's kind of cool. Now another idea I got is to use circles because they're the strongest. But keep in mind, all of this is adding mass. You're adding mass. You're adding mass. Every time you do this, you're making it heavier. But another method of connecting these together would be to have inside and outside triangles or circles. So this one would come from the inside, and this one would come from the outside. Inside, outside, inside, outside, inside, outside. And then you could even connect these all together if you wanted to. There's different things you can do to add. And of course, this works better with transparent materials, because then you get to see all these cool features that you're adding. Okay, let's go to a new design again, since hopefully I still have my copied parts in there. Yes. Okay. So now I need to scale this whole booger down. 220, I want 45%. 220 times 0.45, 99. So I select it all, hold down the shift key, select the height, select this. Let's make it 100 tall. There. Now everything scales uniformly. Okay. Let's see, how do I want to do this? There's something wrong with this frontal piece here. Something's not right. It won't slice correctly. I keep getting little errors. I finally got the print right. It's working okay now, and it's more the lines on the outside are more profound than they should be. So they're more profound on the outside. Although in the case of this model, that actually works. It actually kind of looks cool. I like it because it's like a design feature. I don't know why it's doing it. It's almost like it's almost like the shape is not correct for some reason. I think I know what I did wrong though. I think I know how to fix it. I also forgot to alter the I changed the profile of the slot here to the new design, but I forgot to change the profile on the rear slot. I forgot to alter that one. This is the old design lid, so that's why it fits on the back. And of course, the new design lid is a little bit larger, so the old design still fits on the front there, and that's gone. It's history. Never to be seen again. Let's see. Let's hide you for now. Let's hide you for now. Let's break you apart. So I must have done something wrong with this slotting. Yeah, it's just straight across, right? So if this is... First of all, I hate that. Why is that 99.73? Let's make it 100. Let's make it 99. So if this is 99, then this should be 98.2. Yeah, it's too small. Why'd that change? 98.2. So I wonder how that got changed. And now we center, freeze this part. What did I do wrong? Select both of those, center, align here, shift you, turn you back into a hole, join with this one, but not yet. So that should work. The back was fine. Although I could verify it. So we have that as one piece, yes. This is a completely... Oh, we don't want that to be all one piece. Let's separate this. That is one piece. Ah, that's going to make it hard. That's okay, I can do this. So take this piece. Let's join these together. Let's change the color of this. Stop it. To some other color. Let's align this with the back wall. Okay, now we take this. Now, yep, it's just popping through. We shift it. 0.78. And now we take this piece and align it with this piece on the back side. There, that takes care of that. Turn it back into a hole. Okay, so now my back side is correct again. The reason I have to have this pass through is because you need an opening somewhere. The reason it stops here is because the opening changes to being up here. So the opening doesn't have to be back here anymore. That should take care of that. I did correct this. Although I did want to shift it back a tiny bit. Let's go this way. I can't see it. God, I hate when it does that. Okay, so negative 0.05. Let's shift it back just a hair. What else did I want to fix? Yeah, I need to fix this back slot, which should be easy, actually. Yeah, that shouldn't be too difficult. I'm Groot. So if I take this and I further divide it, there's my cutout tool there. Control D, shift you backwards, rotate. Let's see, this is, doesn't matter. Bring you down to 0. We just need to bring this back to here. There we go. Now, is this one piece? Yes. This and this. Join it. Now we have our new slot shape. Whoa, why is that like that? That should not be like that. Huh. It's not the right. Oh, this got moved. How did that get moved? Oh, that explains the sidewall. This stuff did get shifted at some point. At some point, I somehow shifted this stuff. Oh, I can't do that. This is one piece. Let's separate it. Oh, I don't want to do that. Whatever that was, it was complicated. Oh, this got scaled. That's right, I scaled it. 99. That was my bad. Okay, that takes care of that. We are going to want to expand this just a little bit. Let's just center it. So we take this piece, align on this piece's center. That takes out that chunk. That takes out that chunk. That looks good. This piece, this piece. And that does it. Okay, so now this has the new profile shape to this one. Okay. Now we have the new profile shape on the back. We've adjusted all the ribs. They should now be correctly aligned. I think we're good. Now we take the box and the lid and join. I would rather that this align with the bottom here, like that. And now align this and this. Much better. Now that's one shelf. I can make that a solid layer in the slicer. I hate when I get one of those little hangnails. I can't find my God hands. They work much better for doing that. $45 pair of nippers and I can't find them. That's annoying. Okay. I think that's good. I think order of merge is going to be important here. So let's merge these two pieces. It's going to change to red. Let's change it back to white. Okay, that takes care of that. I really hate this being so inelegant. How wide is this? It is 6.36. So that means we need 12.72. I don't like that either. You know, it doesn't look bad. Doesn't look bad. It's nice and stiff. Yeah, I think I'll just leave that alone. Okay. Anything else I need to fix? What is this height? 4.5. It should be 4.5. 4.5. Huh? Oh, that's not right. That got altered. Yep, 99. Now we're correct. Okay. That's what happens when you make little changes like that. Everything changes. Okay. Anything else I need to fix? I don't think so. All right, let's merge it and see what happens. Merge. Of course, it's got a fetish for red. Okay. I wish there was a way that I can say, how tall is this? And the only easy way I know to do that is to drop a block here, drop a block here, invert this block, and then align these two blocks, merge them together, and now the height, 93.63. That's a really annoying height. Now I know that the height of this section here is 93.63, which is really important for the slicer. Bring back the lid. I don't need the cut tool right now. I don't need this tool right now. Hey, Mike. I wanted to shrink my little box down. This is the big giant box that I made to hold all my juice packets. I wonder, will this hold them? Oh, it's not big enough. It'll hold it in height, just barely. Um, it's just a really nice looking box. But I was running into a problem where this skin wasn't attaching to the slots correctly. Fix that. I changed the profile shape of the drawer, the lid slot, because the actual lid itself doesn't print properly. It's a really sloppy print because the underhang is too great. So I fixed that. I found out that this was going straight through because there's nothing to stop the lid. So now there's a little foot. So when you put the lid in the back, it stops. It doesn't go all the way through. Changed the profile shape of that, but I forgot to change the profile shape for the back slot. So that's now changed to be the new shape. The lid will now print better. This part here will print better. This got shifted, so the outer skin wasn't attaching to the ribs. Fix that. So I went through. I found out that part of the problem was I was scaling. So I tried to scale the entire big giant box down to 45%. And that took me past the 50% critical point. So my 0.02 millimeter slots were now less than 0.01, which the slicer doesn't like. So I've scaled it in the Tinkercad, and I'm just correcting all the little tiny errors. And now we're gonna try to export it. STL. I use the big one, but I think this little one's going to be popular. I think people are going to like this. I mean, I like it. Yeah, see, this wasn't attaching properly on the back either. Yeah, the scaling was just all wrong, so I corrected all that, and you can see on the back here, that skin, it just disconnected and reconnected. This side connected okay. It's the only side that connected okay, and this side is now good. So now I fixed that side, corrected the difference in height for the slot, and so now it should finally be okay. We're just waiting for Tinkercad to take its good old time exporting this part. Oh, this is too big now. We made a 0.73 smaller. So let's make this 94.6, 0.5. Let's make that just a hair smaller. And I can adjust the width of this to make it tighter or looser. Just to make it all more printable. You know, while the lid does print, it prints fine. The underhang is not happy. It doesn't, it prints, it's ugly. So I changed the profile shape from a double wedge to this shape. And this shape is a lot more conducive to printing correctly. I put just the slightest bevel on the bottom here to take care of elephant's foot. Otherwise, this should now print fine. Let's make this curvy box. And this will be curvy box lid. Curvy box mini. Oh, come on, Tinkercad. Export the part. And you can, of course, print this with top or bottom layers if you want. Come on. try restarting it. Come on. I don't know why it takes so long to export anymore. I also realized that I can invert this and get two vases out of it. So right now it prints like this, you know, a nice slim bottom, and it gets fatter at the top. So I can also just do this. I have to remake the model because it needs a 10mm base, but that'll also look pretty nice. So I get two out of that one. I think one of my favorites is the triangle, the 3D. I really like the triangle one. For some reason, it just, I don't know, it just looks really nice. Yeah, I just like that. And the Pentagon one looks really nice too, especially in that transparent orange. I don't know. These print really nice. I really like it. They don't print fast. They're pretty slow print, but they just look nice. We are still waiting for Tinkercad to export the part, so I can double check in the slicer. Come on, come on, come on. Let's get rid of the juice box G code. Oh, did it finish? Yes, I think it finished. This is going to be lid. There we go. Let's make sure you guys can see what I'm doing. Let's see here. Downloads. Load up Simplify. Did it not remember the fact that I changed the name? No, right there. Mini. Oh, there it is. Mini. Now, might as well do this one first since we already have it loaded. There's the lid. That is simple enough. I do not see any complications. I could probably decrease the print time by increasing the layer height. We already did. We're already at 0.24. All right. 0.96. We can print that a little fatter. Export. USB drive. Curvy box mini lid. Yes. Are we correctly set up for temperature? Yes. Okay. Recent factory should be this one. Yes. Delete this. And now we got to drop this in 3 times. 1, 2, 3. And now we take these, we join them together, group models, make sure we're centered, and we're going to split this. Oop, nope. Tools, variable settings, 93.63, add. There we go. So our first section is 4.5 tall. We're going to have, we're not going to do top solid layers in the beginning. We're going to leave it as that. 0.96 is good for this layer. We are going to go down to our normal 0.4. 2 outline perimeters is fine. 0.24 is fine. Honeycomb at 18% is fine. That all looks good. No top layers. This section now. Extrusion multiplier 1.0. I'm happy with that. Let's see if we can get away with 0.24. Because that will speed up the print time. How much will it speed it up? So let's stick with 0.2 first. We only need 2 top layers. That should be plenty. No infill. No additions. 240. And this is the top section. Again, let's keep it at 1.0. Fatten it up a little bit. We're going to go to 2.0. Outline perimeters. I think 4 top layers would be plenty. That'll save us a little time. No, because 4 might not merge with the ribs. Okay. Now we assign this to the first model. We assign this to the second model. And we assign this one to the third model. This is so that we get a manifold top layers. Print, select all, go. That's more like it. Now, if I really wanted to do this cleanly, I would shorten all these ribs by the number of top layers I'm using. But that detail's so small, I'm just not worried about it. There we go. 1, 2, and then that has something to print on. Nice. Okay. And that has something to print on. I actually need 1 more top layer. See? So I have a little gap there. Why isn't this working? Yeah, there. Technically, I need 1 more top layer, but I think we're going to be okay. What's the matter, baby? Come here. You want some petting? I'm sorry, baby. I don't mean to ignore you. Alright. Oh, no, we don't want top layers on that. This should not have any top layers, yeah. There we go. That's what I want. Alright, 10 hours, 53 minutes. Now, how much do I save if I make this 0.24? Probably not much. It's all vase mode. Wow. It saves a lot of time. It saves an hour and a half. Wow. That's actually impressive. Oh, I know why this needs to be 0.24. That's why it didn't seal the top layers. Nope, too much. So that needs to be 0.2. So, 90-minute savings, I'll take it. Now, is there a way I can seal that top? The only proper way to do that is to go into Tinkercad and delete the tops, delete that section of the models. I could do it. I just don't know if I want to. Are my slots forming? Yes, my slots are forming. Even though it adds a lot of time, I added these lines in here. And the reason for that is for when you're printing this. I'll show you. As you see how it gets me this this box on the inside of my infill? It adds a bit of print time, but the reason for that is to make sure the sides of the vase mode print properly fuse with the rest of the model. Watch what happens when I go to the next layer. See? Now that I'm printing the next layer, that layer, those layers, those perimeters there, have something to attach to. What was happening before is the first couple layers weren't attaching, especially here at the corners. See how it's a dead overhang here? If you look at the hexagon, see the hexagon shape here? This would be a dead overhang. And so what happens is this part here, it curves until it comes out and reconnects. So by adding these cuts, I create this box down here so that when it goes to print this blue section up here, it actually has a floor to print on top of. See? Now I have this floor right here so that when I start printing the rest of the box right there, it has something to attach to. Because otherwise there's nothing for it to attach to. It just fixes that problem. Okay. I think I like it. Oh, how do my walls look? There's the problem section right there. Much better, see? See how this section merges with this section? Much, much better. That looks, oh, what's this? What the hell is that? What the fuck is there a gap there for? What the hell? Why do I have an air gap? Why is that starting in midair? 4.5. 4.5. This starts at 4.5. What the hell's the problem? Do I have to force it down? There we go. That was weird. For some reason, it was forcing a gap. That's wrong. That's broken. Why is it doing that? It's broke. What the hell? It's broken on this side too. That's correct. Although that gapping is borderline too much. I mean, it is touching, but that's borderline, needs to be closer. Why are my sides broken? I mean, I did it right. Do I have some kind of overlap setting? Maybe this. No, it's still broken. For some reason, the slicer is erasing my wall here. The toolpath is broken. Single outline. Let's go down to 0.2. No, we still have broken toolpath. Why do we have a broken toolpath? Point four. One way to test this is lower the extrusion and see if it comes back. Now we have a proper toolpath. Okay. So it is the model. The model is broken. Yeah, see how even at 0.3, it's fully embedded into the wall? The other side's probably the same thing. Yeah, it's fully embedded. Somehow I got that wrong? How did I get that wrong? So let's delete the models since they're broken. We have something broken in the model here. Oh, I know what I did. It's because maybe that bottom was the wrong shape. This is 99. No. 98.2. That's 0.8. Oh, I'm an idiot. It has to be 1.6. There's two sides. 97.6. Let's do 97.7. I'm an idiot. I only did one side. The damn wall has two sides. Dummy. Okay. There. That'll fix it. My bad. Why does it have such a fetish for red? God, it always wants to make it red. Okay. Delete Curvy Box Mini. Get rid of the lid and the name. Re-export. I only made it 0.8 millimeters smaller, which only accounts for one side of the model. It needs to be 0.8 times 2 because there's two sides. So 0.8 millimeter for this side, 0.8 millimeter for this side. Yeah, that was my faux pas. Faux pas. Mm-hmm. There we go. 3 boxes. Merge. Group them. You group them so that you can do an automatic center and arrange. If you don't do that, I gotta redo my model assignments. Did I screw up that first one? Nope, it's good. Okay. Now let's check out my center. That looks better. There we go. Now it doesn't pierce the outside, but that's too big a gap. Why is that gap so big? we're not going to get fusion. Yeah, see how there's an actual gap? Why is it doing that? I must have done the math wrong. That looks like it's aligned. Why isn't it right? 99. That's correct. What did I do wrong? Did I do it wrong somehow? 99 minus 1.6 is 97.4. I'm at 97.7. Why isn't this fusing correctly? I'm missing something. Something's missing. No, it's a straight box. What am I doing wrong? And I could just make it bigger, but I'm just band-aiding. The problem. This should be slicing correctly. You know, where's the red part? Oh, I'm sick and tired of this. This fucking piece right here. Well, you're not that anymore. Now you're white. We'll make you gray. Now it's converting correctly. Goddamn red. Hey, Yamaha. What kind of bike do you got? I would kill to have an R1. Oh, I would love to have an R1. Oh, I'd ride that every day just for fun. Okay. I just love the look of the R1. I'd have to get the drag tail for it because I'm a big boy, and the normal length R1 is just too small for me. But my buddy had an R1 with a drag tail on it, you know, the extended tail, and I fit nice on that. Okay. Let's get rid of the old one. Or another gold wing. I love my gold wing. Although I was thinking about that, and I mean, especially if I lose 100 pounds. Yeah, the R6 is too small for me. It's got more than enough power. It's just the frame is just too small for someone who's 6'4" and 450 pounds. You end up so scrunched up that your joints start to seize up. Let's see. Will this work now? Let's see, group models. Let's do our assignments again. That's better. Still not perfect, but that's good enough. The printer I'm currently using is the Odin F5 from Fucus. It's just a decent little machine. I like it. I should make that a little smaller because those are going to make prominent marks on the outside, but it is a valid toolpath. You can probably go back. Ender 3 clone. It's like a slightly nicer Ender 3. See if that still looks okay. Yes, it does. Oh, that's my top layers. Okay. Okay, that looks good. Let's join them all. Let's do them all now. Can I increase that a little bit? Space that out a tiny bit. Nope, it adds the gap again. I don't know why it does that. That is so weird when it does that. It really should not be doing that. It's a glitch in the way it processes the model. Okay. I think we're good. Ooh, we're down to 7 hours, 15 minutes. That's good. Oh, I know why it was taking so long. Because it was printing each of these individually because it broke the toolpath. Now it's printing in vase mode, and that knocks 3 hours off the print time. Damn, that's a lot. All right, this has got the new profile shape. This has got the foot. We have our top layers to clean up this section. I think we're good. So, Curvy Box Mini, yes. Let's save the factory file. Curvy Box Mini, factory file. Okay. We can delete these two and this. Add in the lid. Get rid of the custom zones. Those hexagons are creating a third wall, so I don't need to use 3 perimeters. 2 perimeters enough. 1 hour print. I am happy with that. Export. Curvy USB. Curvy box. Mini lid. Save factory file. Curvy box mini lid. Okay. Better reload it. Okay, select all. No air gap. This all looks good. Okay. We gotta go back to USB drive. Curvy box mini. Okay. That should be the final box. Do our gaps look good? Yes. Toolpath is intact. That overlap is an awful lot. We'll see. How's this look? That looks good. Let's make that final correction. I don't like that overlap. Let's just do it right. It's only going to take a minute. Okay. Let's make it 98. I don't know why I can't use the exact numbers. I think I'm below 0.01 on part of this. And so I think that is causing it to delete portions of the model when it slices it. So I think that little extra that I'm missing is the portion that's being deleted. Let's prepare this. Remove. We are set. Export. Yeah, it's called the. I don't think the company exists anymore. I think they're gone. Focus Odin. I think it's F5. I think that's the printer. It's actually a nice printer, but I think the company's out of business. I think they're gone. And did we export? Yes. So mini, and group. Center. Redo my assignments real quick. No air gap. Good. No air gap. Okay. USB drive, Box Mini, file, save factory file, Box Mini. Okay. That's ready to print. Yes. Somewhere between 150, 160, roughly, give or take 5. Most of them are sitting disassembled in parts inside the Connex container out back. How many do I have in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Got 18 printers in there. And 6 printers out there. We got like 24 printers in the house here. Although I only run one at a time. I don't have the money for the electricity. Each Ender 3 size printer costs about $16 a month to run, and each 334 printer costs about $30 a month to run if I run them 24/7, which I usually do. So I can only afford to run 1 or 2 printers at a time. You know, if I have a project I'm doing and I want to, print a whole bunch of parts, then I can load up 6 printers and say, you print that part, you print that part, you print that part, and then do it. But if I just want to print continuously, I just don't have the money for the electricity. Okay. I like this. This is I think it's going to be really nice. And any printer will be able to print this small one. Okay. Good. Anything else? I don't think so. Now, a way I could handle this section faster. So this part here actually takes a lot of time to print. So if I print just that section there, it's only an hour and 37 minutes. That's not much. I mean, even if I took off half of that print time, that's only going to save me 45 minutes. It's not. It'll take more than 45 minutes to do the modeling. So screw it. Solar panels, yes. It's not that easy though. To run a single printer on solar power so that it doesn't add anything to my electric bill is a lot more expensive than you think. A single solar panel would do it, so $75 and a single solar panel, but now you need the batteries. And an Ender 3 or a what is it? CR6 SE, which is a slightly nicer Ender 3, takes 154 watts of electricity. So 154 times 24 is 3,600, 3,700 watts. So 3.7 kilowatt hours. I need half that minimum. So let's do divide by 1,000. 3.69 kilowatt hours divided by 2, 1.8 kilowatt hours. So a single 100 amp hour battery might do it, maybe. Technically, that's not enough. That's 12.8 times 100. That's only 1.2 kilowatts. I need 1.8 kilowatts. And I need a little bit more for I need slightly more for printing PETG because you run the heat bed hotter. It takes more electricity. So I would need like 150 amp hours. That's actually a lot more than you think. 150AH. There we go. There it is right there, $300. So you're looking at, this one will do it too. 140 should do it. But you'd be better off getting the extra 10 amp hours for $30. But 140 times 12.8. That's 1.8 kilowatt hours. That's actually too small. I need 1.8 kilowatt hours, so I need the 150. So yeah, it would take a $300 battery. Now, of course, that's, now I could run that printer forever for nothing. And you also need a charge controller and with this, all you would need is a charge controller. Actually, with this, I'd be better off. Okay, I don't want a single battery. I need 2 batteries. Do they have 80 amp hour? Oof, big price difference. Whoa. 100 amp hour with a low temp cutoff for $169? Ooh. Holy cow. That's where you want to go. Okay, so the 100 amp hour is definitely the sweet spot here. Yeah, you're looking at $170. So it's still $300, but I need 2. The reason I need 2 is because the printer's 24 volts. If I put these batteries in parallel, I don't need a inverter. I can actually bypass the power supply built into the printer and run it directly off the 24 volt battery. Anything cheaper? 170 is about as cheap as it gets. Yeah, 170 is about the cheapest you're going to get. But yeah, optimally, you want to run off 24 volts. So 2 of these batteries right here, or this one here. Never heard of this company. None of these are prime, which means they're coming from China directly. Ooh, that's still 170. No, that's 195. 175. Now this is actually probably the sweetest deal right here, because it comes with a charger. The advantage of coming with a charger is I can plug that charger into a smart switch. And this way, if I ever have a cloudy day and I don't get enough solar power to recharge, the smart switch, like maybe when the voltage gets too low, the smart switch could switch over to the AC charger. And that way, I basically be using the grid power as a backup power source. That would be the ideal way to do it. And it's only $5 more. So this is what I would do. I would buy 2 of these. So that is yeah, that's the sweet spot right there. This is the sweet spot. So let's see. 175 plus 175 plus, assume I can get a solar panel for $75. I don't need an AC inverter since I'd be running the printer directly off DC power. That's actually nice. Let me save that. Why can't I save this? Where's my options here? Is it all the way at the bottom? Add to list. Here we go. Let's add this to my... Well, I have a whole section just for batteries. UPS portable power. Okay. Hey, Joe, how are you doing? So, let's see. 24 volt charge controller. Charge controller is not bad. Is 30 amp enough? I'm pretty sure 30 amp is enough. Now, which is better, MPPT or PWM? MPPT is better. Ooh, that does jack up the price, but not bad. $20. So plus 20, it would cost me $445 to run a printer off pure solar power, and that's to be reliable. That's a single 350 watt solar panel, which is twice the power that I need, which is good. That's borderline. I need 2 panels plus 75. $520. That'll get me 400% of the power I need at broad daylight, which means even if it's cloudy, those solar panels might produce enough power to run the printer and charge the battery. We would have to add the cost of the smart switch, which is only like $8, and probably an Arduino controller. I couldn't use an off-the-shelf smart switch. Basically, I need a voltage controller. DC voltage controller. Voltage switch relay. I know it exists. I'll have to find it. But basically, I need something that I can set a voltage to and have it trigger a relay if you go below that voltage, and then turn the relay off when you reach a certain voltage or after a certain amount of time, so that if the batteries run low, it'll switch to the AC power supply. There's a way to do that. Looks like it's going to be about $20, I would guess. There should be a way to do that, so plus 20. A proper rig with AC backup, you're looking at $540. That's an awful lot of money. If we do the ROI on that, so we're at $540. Is it worth doing that? The answer is probably no. I want to do it just because I can. Well, I can't right now. I don't have the money. I don't have $540. If I had $540, I'd pay my property taxes, not buy batteries. But you're looking at what did we come up with? 154. Don't you dare do that. Times 24 times 365 divided by 1,000 times 0.137, $184. So 185. It's 0.8. This is how much it costs me per year to run an Ender 3 sized printer. So 540 divided by 185. The ROI is 3 years. So it would take 3 years for me to save enough money in electricity to justify spending $540 to run a printer 24/7 off solar power. Would that be pretty cool? Yes, that would be very cool. Is it worth it? I don't think so. I mean, well, mostly because a 3-year ROI is very good. That's actually really good. Not many cost savings give you an ROI that short. Your ROI is usually going to be 8 to 20 years for most solar projects. Now, there is a cheaper way to do this if I could figure out how to do it. It would save me 1/2 this amount of money. The ROI would probably be similar. It'd probably be a similar 3-year ROI, but the out-of-pocket outlay would be smaller. But I don't know how to do it. I don't know physically how to do it. What I would need is a way to use AC power as a backup power source for solar power. The voltage cutoff relay might be the solution to that. If I had a charge controller that could intelligently turn the AC power on and off, basically I would need a solar charge controller that was able to use AC power to recharge the batteries. I already have two 20 amp hour 12 volt batteries. That's 24 volts. That would be 24 times 20. That's 480 amp hours, or watt hours, divided by 154. That's 3 hours runtime. So that basically be like a battery backup. Now, what I could do is, if the charge controller was capable of sensing the charge state of the battery, and if that charge controller was able to say, okay, your battery's down to 20%, now I'm going to switch on the AC power and use the AC power to charge the battery and keep the battery charged. And if that charge controller was smart enough to not switch the AC off until solar input resumed, so that basically when night came, it would just run off the battery for 3 hours, and then when the battery ran down, switch on the AC power, which would charge the batteries, keeping the printer going. And then when the sun came up and the solar panel was able to resume the charging function, then the AC power would turn off. That would probably give me 15 hours of solar power per day, adding the 3 hours of the battery. Even if I had to buy the components, that's $200. That's a lot less money. And then I'd be running the printer partially on solar power. But I'm not aware of a charge controller, at least not an affordable one, intelligent enough to do that. If anybody knows, let me know. Because there are many things that I can run partially on solar power if I had a charge controller smart enough to switch between AC power and solar power. But I'm not aware of anything that does that. For example, that would be great for my refrigerators. My refrigerators take about 25 watt hours. So let's say a single 12 volt battery. Again, you're better off running at 24 volts. It's less load on the batteries, but that gets more expensive. But let's assume we I think it was 25.4 watt hours times 24. That's 609. And if I doubled that, because I have two fridges, that's 1.2 kilowatt hours. So a single 100 amp hour battery would do it. Would run 24/7. But if I just wanted to run partial, and I ran the fridges off of that, so that's 25.4 times 2, that's 50 per hour. So 25 times 20 is 500 watt hours. So that's 10 hours. I could run the fridge for 10 hours off that battery, in theory. So the lower power your device, the more practical it becomes. I have not seen one yet that will do that. For example, none of these will do that. And these are expensive units, but none of these will do that. Not one of them. that work? No, AC backup doesn't get me anything. I don't know if any of these will do that. I'm not aware of any solar charge controller that you can plug mains power into and it will use the mains power as a backup power source. I'm not aware of any charge controller that does that. I no doubt they exist, but do they exist below $100? um, I don't know. If you could find one, let me know. Um, See, in most cases, you're producing. I need the opposite. Not using the solar as the backup, but using the AC as the backup. Some battery boxes can do that. There are some solar generators that will intelligently use. You can plug them into the wall and you can plug a solar panel into it, and it will prioritize using the solar power before it uses the AC power. There are a couple that do that, but most of them don't list it, so it's hard to find them because that's not how people will use these typically. So what I would need is a charge controller like this that has both AC input and DC input and is capable of intelligently switching between them. And I'm just not aware of, at least not on the affordable end, I don't think any of these will do that. Basically, you would have to have a built-in DC charger that is capable of handling the full output of the MPPT controller. So this here is a 60 amp charge controller. It would need a 60 amp DC charger built into it. Because that DC charger that's powered off AC would have to provide 100% of the needed input. And I'm not aware of any units that do that. It would be such a handy if we had a little, $30 or $40 charge controller that was capable of doing that. Oh, did I switch? Yeah. If we had a little cheap, you know, 20, 30, $40 charge controller that was capable of doing that, even $100, well, that would hurt. Um, but what we need is basically a UPS that works in reverse. See, right now, a UPS takes AC input. And if you cut off the AC input, it switches to the battery. What I need is a UPS that's the opposite. I need a UPS that runs off battery and then switches to AC when the battery is not sufficient. Basically, using the AC as the backup. And it would have to be more than just I detect the AC and the DC. It would have to be able to monitor battery health so that I can program it. Okay, when my battery pack gets down to 30%, switch on the AC input. And then the AC input would charge the battery back up. It would then switch off. And I would say at 80%, switch off the 80 AC input. So once the battery reaches 80%, it would turn off the AC input. And now you'd be running off of the battery again. And if the battery got below 30%, it would switch the AC input on. Basically, a reverse UPS. And I'm just not aware of anything that does that, which is a pity. Because that would allow so many. If we had a cheap $40 or $50 box that could do that, basically we would have a box that would have a port for battery and a port for solar and a port for AC input, or a secondary DC input. Let the user worry about getting the DC power supply large enough, like right here. That's a, let's see, 24 volt, 60 amp DC power supply. Here we go. No, these are step downs. I don't want step downs. I need one of these. That's here we go. That's 10 amp. Let's see. I don't need a voltage converter. I need a 24 volt power supply. Well, yeah, I need AC 24 volt. So I need one of these that can handle 60 amps. Let's try 60 amp power supply. See, I'm betting it's going to cost a lot of money. Well, that's not too bad. Here's 50 amps. That's a 60 amp, but it's only 5 volt. Let's try 24 volt. Whew. $80. We getting expensive. Here's a 15 amp. Can you daisy chain these? Can I hook multiple DC power supplies together? But now you're back at $100 to get 60 amps. I don't need a transformer. I need AC to DC. Let's see. It looks like that much power is difficult to come by. It's kind of what I was expecting. It's going to be expensive. That's not something cheap. Oh, here we go. Here we go, 90 bucks. And you can get it for as low as 55, probably open box. But this will give you 50 amps at 24 volts with 110 volt input. Okay, so you would need I would need some way of switching this on. I would need some automated method of switching this on. I could use a standard solar charge controller plus one of these if I had a way of automatically turning this on and off. And I have no idea how reliable this is. So here's a use like new for 54. I can't afford this, but I'm going to add it to the cart just so I have it. I can come back later and look at it. So 55 bucks for a used one. This is a 12 volt 50 amp for $50. Looks like there's no used ones available. 10% also $45. So this I could use. And see, the thing is, for a lot of my devices, I don't need this one. I don't need 600 watts. I need 2 times whatever I'm using. So 50 watts, I need 100 watts. So I can go smaller for my smaller applications. So let's do 100 watt. Let's go a little above. So we have some overhead. So we're not running the equipment at 100%. Now we're getting more affordable. Okay. So here's 24 volt, 6.5 amp, 150 watt. Perfect. Okay, so 19 bucks. I can get a $19 unit. This is a plug-in? Oh, this might even be better. because it's just plug and play. Literally, there's your DC output, there's your AC input. Yeah, you look for a plug and play one. You're looking at $30-$35 for a. Here's a Meanwell. That's even better. I would go this. I would pay the $23 for a Meanwell power supply. So, for example, to run my refrigerators partially off solar power, this is what I would need. I would need something like this. It'd be even better if I can just use the refrigerator's AC input. But we beggars and choosers. But yeah, you'd be looking at $23 for the DC power supply. But you would also, sadly, need an AC inverter, since these fridges don't run off 12 volts; they run off 120 volts. But for the 3D printer, I would need a 300 watt, because the printer takes 150 watts, and so I would need double that, so that I could recharge the battery as well. So for the printer solution, $50. 150 watt times 2. I would rather have one. $50. Okay. So this takes AC input, gives me 24 volt, 12.5 amps. So $50. So basically the same price as the bigger one. Now, see, the only way this would work is I would need a smart switch. I would need a smart switch that would be capable of switching this on. This would have to be off. And this would only turn on when the battery dropped below, say, 30%. Battery drops below 30%, this would switch on and charge up the battery. Once the battery reaches a certain charge level, this would have to be switched off again. So I would need some kind of intelligent switch that's capable of turning an AC outlet on and off. Here's a 24 volt 15 amp for $24. That's not bad. Okay. I don't know how good a quality this is, but definitely a better price. Here's a decent looking one for $18. And here's a Meanwell. This is better. I'd rather spend here. I can get it used open box for $24. I would much rather have a Meanwell power supply. They're a known value. They're a decent power supply. Actually, I have one of these lying around somewhere. Because I bought one October 2018. I was still in Pennsylvania. That means I put it in a printer. The only reason I would buy that back then is if I needed it. So that means that this is inside of a printer somewhere. So this would be the ideal solution. I can get a used one for $24, and that's only a savings of $4. So yeah, then an IEC. Although I can just go bare plug. But then I would need a way of switching. I would need a way of monitoring the battery health and switching, and then also making sure this doesn't turn on when the solar panels are active. Basically, never turn on unless the battery drops below 30%. Battery drops below 30%, turn on. I would have to use a separate charge controller. Because this won't charge a battery. This just gives you raw 24 volt output. So in order to work properly, I would need 2 charge controllers. One charge controller for the solar panels, and one charge controller for the DC power supply. Now, I wonder if there's dual input charge controller. So are there any that you can plug two inputs into? What does dual battery mean? Literally, dual battery. Battery 1, battery 2. I don't know what that means. Um, it's possible that could work. No, there's no output. This is a dumb controller. No, this would only work if I had a the charge controller would have to have an output for this to work. Because I could plug the solar panel, I could plug the battery into battery one, and then my DC power supply into battery 2. What I need is dual solar input. I do not see one that has dual solar. Because if I had dual solar input, and it could prioritize one solar over the other, so I can give it solar 1 and solar 2, or better would be solar input and DC input. Dual DC. Oh, I don't care about the USB ports. Ooh. See, that's too expensive. See, this has alternator power input. If that's what I think it is, I could plug my DC power supply into that. Yeah, see? You have a PV input and an alternator input. So I could plug my DC power supply into the alternator input and my solar panels into the PV input. But at $319, you're up at the cost of just running everything off batteries now. It's too expensive. I need, like, one of these cheap $40, $50 controllers that has a dual input. Input. Solar, battery. What's that last one? Solar, battery. Okay, is that DC output or? don't know. I just don't know a lot about this stuff. But if I had a charge controller that could accept DC input and accept solar output, I could actually reuse the power supply built into the printer. And if the charge controller is able to switch between them, then all I would need is, a charge controller, a small battery. Whew. I gotta talk to some solar people. That kind of a solution has to exist. But I need something at this price range, $20 to $40 to make it practical. You idiot. You don't understand the first time I hung up on you? I don't know. Am I on the... Yeah, you're on. You can see what I'm doing. Alright, so that's done. Now I just need to print it. It'll be my final print. This should... all the corrections should be in place. And this should now work correctly. That's the correct shape. It's got the stop. This now has the correct shape. The only thing I might need to do is I might need to scale this a little bit until I get it to fit right. But once that's just they'll all fit right, but you want it to fit snug, because what you don't want is you don't want the lid to just fall out like that. So you can see that lid's too loose. That's because this is the new profile where it fits looser. You want it to be even that's too loose. You want it to be a friction fit so that it stays put when you put it in there. Otherwise, you'll pick this up and your lid goes shooting across the room. So the only final change I should have to make is scale the lid until it fits snugly. And then that's it. I should be able to post that. Let's see. EA Sun. Yeah, that's going to be stupidly expensive. It's 6.2 kilowatt. MPPT, solar, hybrid, inverter. Oh, yeah, these are $200. This one's only 100. $2.2 kilowatt, 6,200 watt hybrid. What does hybrid mean, though? Six kilowatts output power, 110 amp. I don't know. I don't know if that actually does what I want. That has a generator input and utility grid input. I think you're right. I think that might be exactly what I need. But that might be the opposite, though. That might be use grid power and then switch to your solar power. I need use solar power, switch to grid power. I'm not sure. This looks like it might have it. See how it has grid, generator, and solar input. But I'm not sure. And this device by itself is going to consume a lot of power because this is designed for a much bigger. And it can't be shipped to my address, so I can't even get that shipped. Let's check Amazon. Solar hybrid inverter. See, these are so expensive. I can buy the I can run the thing off 100% battery power for these costs. Even this one here, 1 kilowatt, is $200. Yeah, 10 milliseconds is what you need to make sure it's not going to ow your to make anything above 10 milliseconds, and your printer might reboot when the power switches over. So that's your switch over time. As long as your 10 milliseconds or faster, it should be fast enough. So this would be good for like the fridges, theoretically, since it has the although it's way more power than I need. But see, I don't need switching from utility to battery. I need switching from battery to utility. I need the opposite. It does have that. Solar first. Okay, so you can tell it to use utility first or solar first. If that's what I think it is, solar first should run everything off solar power unless the solar is not enough, then you run off utility. Utility first would mean use utility, and the solar is a backup to the utility. Well, the only problem is it's $200. And it's got 10 times more power than I need. I don't need 1,000 watts. For something like the fridge, I need, 150 watts. Well, I also need an inverter. For the printers, I don't need the inverter because the printer runs off 24 volts. So as long as I'm using a 24-volt battery and a 24-volt controller, then I can run the printers directly off the 24 volts. Well, yeah, but if I have that kind of money, then I'm not worried about this. I'm trying to find a affordable solution for doing something now. And this is designed for a much bigger application than I need. I need something, that's 200 or 300 watts, not, you know, 2 or 3 kilowatts. See, 2,000 watt, way too big. 2,400 watt, 5,000 watt, 10,000 watts. This is for your entire house. Yeah, 12,000 watts. Jesus. 10,000 watts. Yeah, this is designed for much, much bigger. Just for the hell of it, let's put 500 watt. See, this is just an inverter. That's just an inverter. Here's a solar hybrid, but again, it's 3,000 watts, $500. That's just an inverter. Too expensive, too expensive, too expensive. All too expensive. These are all kilowatt level. 3 kilowatts. That's just an inverter. That's a grid tie inverter. I think this is just for connecting your solar panels to your controller. I don't think these are independent. Oh. I gotta look. Right, this is sort of what I need, a solar first hybrid inverter, but I need small scale. Ooh, that's way more than I need. Oh, hey, it's still a bit on the expensive side, but this is kind of what I need. Works like a UPS, but in the opposite direction. The controller will switch to grid when batteries are low. Low to cutoff point. Once the batteries are back to recovery point, it'll switch back to battery power. This is what I need. It's just massive overkill, though. Give me something half this price and half this power. I don't need 50 amps. 55, even for running a printer, I only need, 400 watts. 300 watts is what I need, plus a 100-watt overhead, so you're not running at 100%. I need a tenth of this. I'm going to save this one, though. I'm not going to get it, but I'm just going to add it to the cart so I have it for later. Why would you do that? I didn't want you to switch. If I wanted you to switch, I would have asked you to switch. Asshole. Public output inverter. Oh, this doesn't have a built-in inverter. It does have DC output though. So here's your AC input. I mean, is this all AC? So is this all okay? Yeah, this is all AC. So what's the output for? Because you have inverter. Why would you have inverter and output? Transferring back to the inverter is a 16 millisecond switch over time. For something like the fridges, that's fine. But for perfect transfer, when the battery is down to 75%, switch to public power. When the battery gets back to 75%, switch back to battery power. Okay, I see. You would have a separate charge controller for the solar panels. So you would have the solar panels through a charge controller connected to the battery, and then the battery would connect to this. And this would switch between the battery. So it looks like it does have an inverter. Now, why is it saying I need an inverter from the battery? Now, see, here's what I'm talking about. Main power, secondary power. So main power, DC or battery. Secondary power, DC or battery. Okay, so it looks like it can do exactly what I want. So I would plug main power into this, my DC power supply into this. Can it do DC all around? No. And no. Okay, so it looks like it has to all be DC or all be AC. So I should be able to skip the inverter output, and I could have my main power be the battery with the solar and the charge controller. Well, no, I don't, because I'd be using a DC power supply. So secondary would be the Meanwell power supply, a 350 watt Meanwell power supply. So basically, my power supply would be the inverter. Would you go to fuck away? Thank you. So if you look at the screen here where it says main power, really? I forgot this is a touch screen. So main power would be my my battery pack, and that battery would have a charge controller and a solar power panel connected to it. Secondary power would be the Meanwell DC power supply, which would plug into the grid. And then I wouldn't need the inverter for the output because I wouldn't be going to AC. The output would simply go to the printer. The only problem is this doesn't turn the Meanwell power supply on and off. That's the only problem. Which means the Meanwell power supply would be running 24/7. It wouldn't be consuming much power. Well, only because the printer takes so little power. So maybe what I need is an automatic transfer switch. So let's try searching for that. DC. Oh. Now, wouldn't that be nice if something like this worked? And a 7.5 millisecond transfer time? 7 millisecond? So DC power source, battery. Okay. So I would hook the battery to the battery input, the DC power source into the DC power source. Looks like it handles 30 volts. So I can run 24 volt power into this. And then this would be the load. So the 3D printer would connect to load. The Meanwell power supply would connect to DC power source, and it would plug into the wall. The battery would be my 24 volt battery pack with its own car charge controller and solar panels. I'd still be in the same boat where, although which one's priority? Although that doesn't actually matter. Whichever one's priority, I just plug the solar panels into that one. Automatically switch to battery terminal as power supply if main DC terminal is off. Well, that's not good. It says there will be a temporary power failure for about less than 1 second. Now I could fix that by using a regular UPS, but now you're, hey DeWitt, how are you doing? That switchover time might be too much. But man, $6 is tempting. But now this is 30. This is a high-speed ATS, okay. So here's priority power and backup load, backup power. So what I would do... Oh, wait a minute. It's only got a 5 amp limit? What kind of water issues? Okay, so this is too small. You probably only get 300 watts at the so 5 amps at 60 volts, or because 12, that's only 450. Well, 12 times 5 is, that's only 45 watts. So this is useless. This is exactly what I need, but it's too low power, oddly enough. That would be great for low power stuff that already runs on batteries. Again, it jumps straight up to this huge shit. Again, 100 amp is way more than I need. It's also 220 volt. This is only 45. Whew. Wow. Yeah, I guess while you're in there, you might as well inspect it. At least they used their brains and did that. Let's do high speed. So this is precisely what I need. It's fast and it does exactly what I want, but it's not enough power. 5 to 60 volt, but it says 5 amps. Max current 8 amps. Oh. Oh. Woo. Let's see. So 24 times 5, that's only 120 watts. That's not even enough to run the printer. 24 times 8, that's 192. That is enough technically. It's pushing it though. I mean, but technically it is enough. But the thing will be running at 100% all the time. It's probably not going to last long running at 100%. I mean, granted, I don't need it that often, but... So I would plug the battery pack into the first one, and I would plug the Meanwhile power supply into the second one. I mean, good news is I'd only need a 200 watt power supply since that's all this can handle. Basically, I would plug the solar panels. Oh, this might even handle the switching. basically I'd plug the solar panels into the first one, and I would plug the DC power supply into the second one. I need double. I need 10 amps. 5 amps is just not enough. That's too much money. There's got to be a faster solution, an affordable solution to this. This is all bigger. This is all too big. Yeah, it's too big, too big, too big. This is all too big. This is all too big. No, almost definitely not. Um, to run a 3D printer, you need about 50 watts. But that's without a heat bed. Okay? So you got to take the 50 watts, and then you have to add to that anything non-standard. Running a clipper controller with a screen, that's more power. You need to account for that extra power. Running a heat bed, you need to account for that power. Now, what is a Tri-Zero? Might be enough. What's a Tri-Zero? I don't see a Tri-Zero. Oh, it's a Voron. What's a Tri-Zero? Are you, let's see, hang on. Videos? Oh, here we go. So something like that? Is that the thing you're currently building? All right. So is that a standard controller or is that a color screen? And you also have to remember you're going to be pulling a lot of power since Vorons tend to run fast. So you're going to be running, relatively high voltages to your motors so that you can get that high speed. Um, it's all going to depend on how much power your printer's consuming and how much power that heat bed is consuming. Now, you can run a okay, so that touchscreen is going to consume more power. So 100 watts probably not going to be enough. Your printer alone is probably going to consume more than 75 watts. Yeah, you're probably going to need the 150 watt. Unless you go low power on the heat bed. If you don't mind waiting longer for the heat bed to heat up, a bed that size, if you're not printing ABS or nylon or anything like that, meaning 80 degrees centigrade maximum, you could probably get away with a 20-25 watt heat bed. Because you really don't need, like, I can heat up an Ender 3 heat bed to 50 or 60 degrees, using a 25 watt block heater for a car. Um, so you could probably get away with a 20 watt heat bed if you can get a heat bed that low power. But if you can get your heat bed below 25 watts, that leaves you 75 watts to run the printer. That might be enough. You might be able to get away with 100 watts. How much power does the existing heat bed cost? Power, not price. I am Groot. I'm looking it up right now. Okay. It's a 75 watt heat bed. 24 volt, 75 watt. So you're actually pushing it with a 150 watt power supply. You're pushing that 150 watt power supply pretty hard. If you can get a lower power heat bed, then you might be able to do something. That's a 100 watt. There's a 60 watt. Yeah, what you need is a low power heat bed. Right now, it looks like your standard heat bed is 75 watts. Yeah, that's why I'm saying your printer is going to take about 75 watts. I'm thinking your printer alone is going to consume around 75 watts because you're going to be running the motors at a higher voltage because you're going to want speed. As far as the Z-axis power consumption, that's irrelevant because the Z-axis is not continuous. X and Y is continuous. The print head is always moving around, but the Z-axis doesn't really matter because the Z-axis isn't continuously moving around. The Z-axis is move, stop, move, stop, move, stop. So the Z-axis only needs extra power, for a second. If you can get a low power heat bed, then you might be able to run it off the 100 watt power supply, maybe. But even that, you'd be pushing that power supply to 100% all the time. Hell, your 150 watt power supply, you're going to be pushing that thing well above its 80% rating. You might have power sag, even with the 150 watt, because your heat bed, well, the heat bed is only going to consume 75 watts while it's heating up. Once it reaches operating temperature, the power going to the heat bed will drop. I don't know. Barbie. Of course, you make sure you print the Barbie doll. Maybe put a pair of panties on top of the printer. Do a callback to that what was that movie where the kids they tapped into the military computer and the missile came through the floor. Weird Science. That's the movie. Do a callback to Weird Science. Oh, that was a good movie. There you go. With a Barbie doll inside. Oh, that's great. You're a moderator, so go ahead and post a link to your channel so other people can go see your build. I am Groot. I'm actually thinking about I want to build my own printer. It's just something I've always wanted to do for the last like 7 or 8 years. I've wanted to build my own printer, and basically I want to build an Ender 2 as small as I can, um, as light and as small as I can. I want to try to use 10 millimeter rails, and I don't know how small it is technically possible to go before things start to get wobbly. But I also want to keep a decent build volume, although I'll probably go down to 100 cubed. So 100 by 100 by 100. Woo! 50 watts for the nozzle. Now, that is on off, but still, yeah. You need 150 watts. But I want to get basically I want to build a 3D printer out of this stuff. 10 millimeter rails. So these are 10 by 10 millimeters. So half the size of the current extrusions used on the printer. Actually, 1/4. You would have to put 4 of these together to equal the current 20 by 20 being used. Oh, I didn't switch. These here. So basically, the 4 of these together would be equal to 1 20 by 20 currently used on the free printers. The but I want to try to build. Basically, I want to build an Ender 2 out of that. A half scale Ender 2. It'd be a little bit more than half scale. It'd be about a 60% Ender 2. I would like to try to do that. Oh, I bet. The thing is, do they make a micro hot end? Do they make a hot end that's smaller than a Creality hot end? You know, because it's already a pretty compact hot end. And this will be cantilevered. It won't be a box. If you make it a box like an Ender 3, this is easy to do. I was thinking about doing that too, making a half scale Ender 3. Just for shiggles, for shits and giggles, just because it would be fun. That's the only reason why. It'd be fun. That might actually be easier to start with trying to make a half scale Ender 3. Just by having the box shape, it just makes it a lot stronger. I'd probably have to print all of my wheels. I don't know if they make. The bamboo hot end's pretty big. You think the bamboo's hot end is small because the piece you replace is small, but it's modular. It'd be pretty hard to get smaller than a Creality hot end. I mean, Creality hot end's pretty small. There are actually things I can do to make the Creality hot end smaller. I can shave down. I can literally grind down the heatsink, make it smaller. Grind down the heat block, make it smaller. So there are things I could do to. I don't need it to be lighter. I just need it to be physically smaller. That's what I was thinking of that new where the yes, it'll have a heat bed. At least I want a heat bed because I print mostly PETG. Hmm. It's something I gotta think about. Most of the expense is going to be buying bearings and screws, basically. I'd be using a lot of M1 hardware. Are the ends of this thing threaded? I can't tell if the ends of this are threaded or not. Like this hole here, that's a 2.5 millimeter hole, so I'd use M 2.5 hardware to thread into there. Would that be neat to have a printer with a 80 millimeter cubed hot heat bed? So 80 millimeter cubed build volume. That would be just about 1/2 scale for an Ender 2. Because an Ender 2 has a 160 by 145 by 225 build volume, 200 build volume. What was that? Uh, 165 by 165 by 180. But the reality is, you can push that pretty close to 200. Really? Nice. But still, I would never give up a 500mm printer. I'd be running that thing every day. There's still a project I want to do. I'm hoping to find somebody who can help me paint it and make it look nice. And so I might print 2 of them and give them one in compensation for the paint job. But I want to print a full-scale Neytiri from Avatar. That would mean, 9 feet tall. Because those critters are 9 feet tall. People don't realize how big they are, but they're big. Almost 9.5 feet tall. I would love to print one. I would love to have just in the center of my living room a full size, Neytiri character. That would just be awesome. I've never seen anybody print one full scale. The company that did all the color work, they have a couple of full scale ones in the front of their place. If you watch, is it Adam Savage, his videos? No, I haven't. Holy shit, nice. 35 rolls.
What is going on, everybody? Jerry with 3DHP. We got another alien video. We'll get into it right after this.
Jesus. Holy crap, dude. Yeah, if you're going to print an alien, that's a hell of an alien. Wow. Look at him trying to reach up and print that. Wow. That's incredible. That's amazing. And the nice thing is, there's no smooth part on that model, so it'll easily hide any imperfections and crap like that. Wow. That's ridiculous.
I am Groot.
Oh man, that's impressive. 5 months ago, and he didn't bring it to Rocky Mountain Rep Rap, or did he not go to Rocky Mountain Rep Rap? Wow, that's cool. That is so freaking cool. These are transferred, so I can begin printing this. Jesus, that's cool. Wonder what models are available. I did find one that looks like I could scale it up. Oh, he's in Las Vegas. That's not that, well, yeah, that's pretty far. As long as he can separate it into like 3 pieces, you need a van, basically. Well, it looks like we're getting rain tonight. That's just a bust, which I might print, but that's not what I want. Let's check the thingy. I think there's a free one available on Cults. Yeah, this is the one I saw. But the one had a... Yeah, see, her face is all wrong. See? Her face is completely wrong. That is not what her face looks like. That's the only problem. And her face is the most important part of the model. And it looks totally wrong. See what I mean? That's not what I want. There we go. Stop it. That's what her face looks like. Really? Fucking web peas. But see, this is what her face looks like. That looks absolutely nothing like that. I mean, I'm sorry, that looks like a... looks like shit. I would never want to print that. That is just simply not what her face looks like. It's not even close. It sticks out too far. The nose is different. The eyes are wrong. Her face does not stick out like this. They have a very flat cat-like face. See? Not even close. It's not even slightly the same. Whoever that is, it's not Neytiri. And the problem is I want the full body. Oh, that just looks sinister. I don't know what that is, what that creature is. Oh my god. And it's just wrong. It's not her head. It's just straight up not what she looks like. That's a tiny bit better, but still, the nose is not wide enough. The face sticks out. Look how far her face sticks out. Her face is squished. It's flat, like a cat. And the lips are too big. The eyes are the wrong shape. Every one of these is just horrible. Now I wonder. Woo, it's raining hard. How does the bust look like? If the bust has a better head, maybe I can combine the bust with the body. That's a little better. Can't I move this? I need this to move. How do I translate? So I can't translate the fucking model, really? Now that's better. That's the proper shape, the flatness. It's got the wider nose. The eyes still don't look right. And it's low resolution. If I printed this 9.5 foot tall, it would not be very good. Now, there might be a better quality model available in Colts. Jesus. Did you see this little boat the guy made? This little boat's awesome. Cup holder. Nice. Mouse needs to be charged. Me too. I mean, that's not horrible. I've definitely seen worse. I hate the fact that Cults won't let you download unless you have an account, even for free files. It's really annoying. Why do I have to ask for a new password? I don't want to ask for a new fucking password. I'm just gonna ignore Cults 3D if they force me to use a different one. I hate when sites force me to change my password. It really makes me angry. Oh, the power just blinked. Probably went right to the spam folder. No, it didn't. So they're just not going to send me the password reset at all? Oh, for Christ's sake. Come on. The mouse is dying. I need a charger. Where is my spider? The fuck are you attached to? Oh. There's my spider. I need this one. There we go. And there goes the power. And the power came back on. And, of course, Cults 3D password reset doesn't work. Ooh, what's that smell? It's gone. It was outside, whatever it was. Boy, that's a lot of rain. We don't normally get that much rain. So if anybody knows where I can get something like this, I need this that can handle more watts. You know, this has the voltage, 5 to 60 volts. That's good. It has the speed, 7 milliseconds. What I need is more wattage. This only handles 5 amps. I need 10. 10 would give me 240 watts. That would be enough. But yeah, that's basically what I need. 240 watts would do that. Ow. Ow. It's an automatic transfer switch. I can't afford to run the whole thing off solar panel. I would take, $275 batteries to run the whole thing off solar power. But if I could just run it on solar power during the day, that would work. And the ideal way to do that is with a transfer switch. Because then I don't need a big battery. I just need a little tiny battery. A 220 amp hour batteries would do it. Do you? Just be careful with the ones that are not lithium iron phosphate and using them in your house. Be careful. Just look at my video. That damn thing almost burned my house down. Because some of them use NMC cells because they're smaller, more compact, higher power output. But the problem is they usually have piss poor charge controllers. And once they start overcharging the battery, yeah, it gets bad. So make sure the ones you are using continuous. Just sitting on your shelf, it's fine. And the power might go out again. I'm talking about if you're using it as a UPS. If you're using any of them as a UPS, good. Lithium iron phosphate is far less likely to burst into flames. Damn. Well, we don't often get rain that hard. And doesn't usually last this long. But this is basically perfect, except for the fact that it's only 5 amps. 8 amps is technically enough, but you're pushing it. That's a lot of power to be drawing. Nice. You see, even at the max current, that's 24 times 8. That's only 192 watts. That's what the printer requires. Which means I'd be running the damn thing at its max current 100% of the time, and that would be very bad for it. This is designed to run LED lights. Uh-huh. Scary, isn't it? Yeah, I stick with the lithium iron phosphate only. Oh, I see. This is interesting. They're using this to run a little camera. Okay. But this is what I need, except that it's a little more than I would like to spend on something like that. But it's just too low power. I need higher power. It's not a matter of max output, it's a matter of max input. Now, EcoFlow probably can take a pretty good solar input. The problem with the cheap ones is that for example, the the Bluetti EB3A. That's a sweet little battery box. It can fast charge on AC power. It works as a UPS. It has a 600 watt output. Oh, I was just looking at this thing that I was looking at before. This transfer switch thing. No, you don't. The printer will run off of DC power. So I can run the printer directly off the battery. So the EB3A seems like the perfect battery, right? Except it's cheap. You can get them refurbished on eBay for like $140 when they're on sale. They have two problems. One, I've had the cooling fan fail. Now, good news is when the cooling fan fails, the battery stops working. It stops charging. It's smart enough to know that, hey, I can't charge when this fan's not working. But the problem is they don't honor their warranty. I've been trying for like a year now to get them to replace the battery. And they just keep asking me, send a picture of this, send me a video of this. And I do all that, and then they just stop replying. So I don't trust them. The other problem is that the solar input's only 120 watts. It's 100 to 120 watt solar input. Now, for something like running my fridges, that's fine, because both fridges only consume 50 watts. But you can't use the 600 watt output. If you plug a 400 watt load into it and you only have 120 watt solar input, well, you have a deficit there. It's not going to work. So a lot of the times they do not have a solar input that matches their output capacity. So yeah, sure, the battery will put out 600 watts, but you can't charge it at 600 watts unless you plug it into AC power. So while you can use it for a UPS, you can't use it for off-grid, at least for anything above 120 watts, because you'll exceed your solar input. But what I could do is I could plug $150 of solar panels into one of my existing, two 10 amp hour batteries, which I have tons of. Let's see, the two. So that would be 25 times 10. That's 250 watts. So I'm not exceeding the BMS in the battery. I could plug in two 10 amp hour batteries that I already have. Now that would only run the printer for about an hour, but that's okay. Because what I can do is plug a Meanwell power supply into this second input right here. And when the battery gets low, switch over to the Meanwell power supply. But there's the other problem, is that how do I get it to do this when the battery gets low? The easier solution, if this is something that I can figure out how to do, what I need is an AC smart switch that can read the voltage of the battery. So all I would do is solar panel, charge controller, battery, printer. And now what I would do is I would have a second charger. I would have another solar charge controller, and instead of plugging a solar panel into the charge controller, I would plug the Meanwell DC power supply into the solar controller. So the solar controller would think it's getting 25 volts from a solar panel, and then it would then charge the battery. What I need is a way of monitoring the health of the battery, and when the battery gets down to 25%, turn on the Meanwell power supply. No, it's never going to run the Keurig. Okay, coffee machines are high-power devices. Even small coffee machines are usually 700 to 1,000 watts. And the good ones, like a Keurig, is probably pushing 1,400 watts. So you would need a significantly larger battery. The power output is relative to the number of cells inside the unit. Each cell has a maximum output. And to get a larger output, you need a larger cell. These are the low quality cells that you see inside these units. So you would need a 1.5 kilowatt battery if you want to run something like a Keurig. You would need something with you and go with something good, Blue Eddy, EcoFlow, River. Go with one of the Jackery. Go with one of the decent ones. But you would need 15-watt solar battery. So here we go. You would need something like this. No, you're still consuming the same power, and it's most of these devices, believe it or not, they're okay. It used to be in the past that running DC was better than running AC because there's no conversion. This is not true. These devices do not have 12 volt or 24. These devices do not have 12 and 24 volt batteries inside them. They have 18650s, 21700s. They have little cells inside of them, and they're usually running around 36 to 48 volts, sometimes higher. Like my EB3A, I believe, is a 36.2 volt battery pack inside of that thing. So you actually have two inverters inside there. You have a DC-DC inverter or converter, and you have a DC-AC converter. Because most people are plugging AC things into these batteries, they've been improving the AC inverters. Most people don't use the DC ports. That's just I have my car charger on me or something like that. So believe it or not, the AC inverters in the modern batteries are actually significantly more efficient than the DC-DC converter in these batteries. You'll actually get longer runtime using the AC inverter. I know it's counterintuitive, but look at the who's the guy? He wears the gloves. And he says, "I'm going to take the battery into my lab and do dirty, nasty things to it." I love watching him. But in all of his tests, the AC inverter is about 10% more efficient than a DC-DC inverter. On top of that, most of these devices are limited to 8 to 10 amps on DC. That means 100 watts, 120 watts. So you're not running a coffee machine off that. Unless you buy a automotive vehicular coffee machine, meaning something designed to run low power DC. So no matter what, you're using the AC. This device here has a 1 kilowatt hour battery and a 1500 watt output capacity, and it's lithium iron phosphate. It's about $400. That's about right. That's about what you're looking at on the low end to run something like a coffee machine. And this is not a tiny unit. That's a pretty big unit. Here's a 1.2 kilowatt hour for $350. Lithium iron phosphate. If it's not lithium iron phosphate, don't touch it. Seriously, it's not worth it. It's just not worth it. Here's an Anchor Solix. This is nice. 1800 watt, 2400 watt peak, 1 kilowatt hour, $600. You see, you pay a lot for that name brand. Let's see. This is a 1100, 1.2 kilowatt hour. Believe it or not, capacity doesn't matter much. Once you get into the kilowatt hour range, that's more than enough for your CPAP, and that's more than enough for a coffee machine. What you need is power, not energy. So to look at this, for example, this is how much power you have, 1500 watts. This is how much energy you have, 1036 watt hours. So power is how big of a device can you plug into it. Energy is how long can you run that device. So if you were, now keep in mind, this number is actually not fixed. It's variable. The higher the load you plug into it, the lower this number is going to be. The smaller the load you plug into it, the higher this number will be. This number is at minimal load. So if you were to plug a 1 or 200 watt device into this, you'd probably get about 90% of what they're claiming here. You'd probably get pretty close to a kilowatt hour. If you were to plug a 1500 watt coffee machine into this, you're probably closer to 700 or 800 watt hours. But you're only running the coffee machine for 6 or 7 minutes. So you're drawing a lot of power, but you're not actually drawing a lot of energy. So if you plug in a 1500 watt coffee machine, divide by 60, that means you're consuming 25 watts of energy. You're just consuming it really quickly. So 25 times 8, you'd consume 20% of the power in this battery to make one coffee. So that would be enough. You have 1,036 watt hours. You're going to consume about 200 watt hours in the 6 or 7 minutes it takes to run your coffee machine, depending on how much power it consumes. If you look on the back, it should tell you how much power it consumes. Maybe it's only consuming a kilowatt. I don't know. But either which way, you're probably going to consume 180 to 200 watt hours of energy from this machine, which means this would be enough power to run your coffee machine 4 or 5 times. Now let me show you the problem with this one. Let's see, input 12 to 32 volts. This doesn't have direct AC input, really? It says it recharges in 2 hours. That's only a 500 watt charger. So can it actually take 500 watt input? Okay, solar 6 to 10 hours. That means you can only put 200 to 250 watts. You're looking at less than 200 watts solar input. So that would be now running a CPAP, that's no problem. Even running your Keurig, that's no problem. It would take you about an hour to recover the energy you used to power that Keurig for 6 or 7 minutes. So as you can see, this is one of the reasons this unit is only $400. Is that it only has a 2 or 300 watt solar input. It'll probably tell us here somewhere. 5-year warranty is good. The fact that they're not listing the solar input means it's pretty low. MPPT input. I wonder if this can actually charge off of the 100 watt USB-C input. That'd be pretty cool. I like the way it shows separate input output. That's nice. Here we go. Wow, it has 200 watt USB-C. That's nice. Is it bi-directional though? I don't know. Let's see. It's not telling me what the input is, and that's concerning. Specification DC input 200 watts. So that's why this battery is so much cheaper. Now, if you look at a more expensive battery like this Anchor, which is $200 more, this is where you'll see the difference. So it has direct AC input, and you see that little yellow connection right there? That's your XT60 input. Let's see, what is the solar input? See, this has 600 watt charging. So even this one's not full power input for charging, but it's 3 times the input power for solar. So you could actually use this for reasonable applications. You're not going to be able to plug, a 2 kilowatt device into this and run it continuously on solar power. Your maximum continuous load is going to be 600 watts because that's your maximum solar input. So you could plug like a kilowatt of solar panels into this so you can get your 600 watts effective input. So this, you would plug your coffee machine into this and run it for 6 or 7 minutes, and it would recover the energy you used in less than 20 minutes. So that's one of the major reasons, and the name brand. But that's the reason that's the whole reason this one is $400 and this one is $600. You got a bigger inverter. You got 900 watts, or no, it's 1800 watts. It's only slightly bigger. But this will let you run a skillet. This will let you run a small heater because you can, it's 1800 watts. But it's also got that 600 watt input. And that 600 watt input is a big deal. And it's got a full power AC input. So it'll charge at 1500 watts on AC power. But that's what you're paying for. You're paying for that higher solar input if you actually need it. You can also plug extension batteries into this. All of them, Bluetti, Anchor, Jackery. Isn't one called River? I think River's a model name of one of these brands. But a lot of them have, for the bigger units, you can stack extra batteries. So there's a plug. Actually, I think you could see it. Come on. Yeah. That little plug right there on the side. See that little plug in between the two? It's either that or it's on the back. There's you can extend it. See here? So you have this extra battery that you can plug into this unit. That plug is probably where it plugs in. And so this would double your capacity. This is basically the same as this without all the ports, inverters, and all that stuff. This is just the battery itself. And you can plug this battery into this battery and double your capacity. So now you have 2 kilowatt hours. Woo! Nice. Very cool. That's a big battery, buddy. 5 kilowatt hours. That's 4 or 500 amp hour batteries. Whew. That's a lot of batteries. um, yeah. See, this one's almost the same price, but it's half the power. 538 watt hours. This looks like a ripoff of the EcoFlow batteries. Looks just like the EcoFlow batteries. Ow. Here's a Jackery. Wow, that's decent. But man, you're paying for it. That's a lie. Actually, that's not bad. 880 watt hour? Wait a minute, there's no way. Yeah, it's 1,000 watts. It's not 3 times 1,000 watts. It's 3 times AC outlets, grand total 1,000 watts. But still, 880 watt hours and 1,000 watts for $350? That's pretty good. What's the solar input limit? Why the hell are these pictures? Is this a scam listing? No, it's from Jackery. It's a refurb. That's why it's a refurb. But 880 watt hours and 1,000 watt output, that's nice. I hate this. I hate this automatic turn off thing. I wish there's a way to disable that. Locally through Marketplace and Craigslist. Trust me, brand new. They're very expensive. Like back in Pennsylvania, Craigslist is the place. Here on in New Mexico, nobody uses Craigslist. Everybody uses Marketplace. So you go into here and ooh, old military generator, huh? Where's my search? Here we go. Oof. That's such a deal. But I am broke. They're only 230 watts, but still $25 each. Yeah, they all have to be the same. You gotta buy them all at once because all the panels need to be the same. And you need to check the specs of whatever you're plugging into for voltage and for how many panels you can plug into it. So you see here, these are 30 volt panels at 8 amps. So these are 8 amp 30 volt panels. These are pretty small. Oh my God, though, $25. Even better if you buy them all. Wow. Is it 48 times 25? Oh, that's with the inverters too. I don't need the inverters. Well, if you're doing a solar array, you would need inverters. But for mounting them on top of my car, I don't need the inverters. Oh, I wish I had some money. $25. $545 watt panels. Nice. $100 for a 305 watt panel. That's common. But see, like if you were building a solar array, that's rough, dude. The only problem with buying a solar panel like this is it's only good for a one-off rig. Like this would be great for get one or two of them for running a 3D printer off grid, for example. But for hooking it up to like your house, this is a bad option because all the panels need to match. You can't mix panels. See, I would love to have, 3 of these and mount it right on the roof of my car, and then I could charge my car when I'm parked. Oh, that's such a good deal. See if I can get like 6 or 8 of these. It's only $200. I just don't have it. But 8 of these would run my mini split off pure solar power. Damn. That would be nice. But what are you gonna do? Shipping would be crazy. It would cost a fortune, and you'd have to pack it like a TV, with foam edges around it. Otherwise, it just gets smashed. Yeah, no, if it without being able to properly package it, and then the cost of the shipping, nah, too expensive. I know I couldn't afford it. That's for sure. Now compare that with buying solar panels used or new. These are all tiny panels. These are all stupid tiny panels. Come on. Really? Here we go. $349, $205. That's actually not bad for a brand new panel. You know, 300-watt panel for $205. They're a lot more expensive when you buy them new. So your best way to get panels is to hit your marketplace, look for a deal like this right here. These are used panels, but they still have another 10 or 15 years left in them. You just might not get the full 230 watts. Maybe they'll only put out 200 watts or 190 watts. You just add more panels, no big deal. I mean, if you bought all 48 of them, I bet you he would take $1,000. I'll bet you $100 he'd take $1,000. So 1,000 divided by 48. That's $20 a panel. It's $21 a panel. You can't beat that with a 10-foot stick. If you run them 2P at 60 volts, say, for example, that's 48 times. Let's say you only get 190 watts out of each panel. That's still a 9 kilowatt array for $1,000 fucking dollars. Jesus. Well, at that point, you'd probably need the inverters, so you just pay them the $2,000. That's 9 kilowatts of solar panels for $2,000. Wow, that's actually enough to power my entire house. But you need a lot more than just this. You would need the grid tie inverter and the professional installation, the mounting hardware to mount them. You can't just lay them out in the grass. That's not quite how that works. I will not put solar panels on the roof of my house. It's not worth risking damaging the roof. I've got 1.5 acres. I've got plenty of land to ground mount them. Hell, I can mount them to I got 900 square foot of shipping sea containers right behind my house. I'll mount them on top of those all day long. And I got almost 1,000 square foot of carport. I can mount them on top of those. That's 1,800 square feet. That's bigger than my house. And that's without touching the roof of my house. No. I will not touch the roof of my house. Nope, I'd mount them on top of the carport, and I'd mount them on top of the sea containers. But I could never afford any of the stuff to go with it. Even if I could somehow come up with the $2,000 to buy this, you would still need the grid tie. You would still need the hard mounts. And then I could not go on top of the containers and mount them myself, so I'd have to pay someone to install them. You'd still be looking at another, at least $2,000 or $3,000 in work to grid tie, and then that would not erase my electric bill. It would only reduce my electric bill. Let's see. That is 9 kilowatt hours. Times 10 times 365. That's 32,000 kilowatt hours. So that would only be enough to I'm sorry, 32,000 megawatts, because this is kilowatt hours. Hello? Hi. Hi. What's up? Oh, hang on a second. Hang on 1 second. All right, that's it. I'm gonna scram for I forgot I had this appointment at 3 o'clock. So I will talk to you guys later. I'm gonna get this printer going, printing this out. Make sure this box works correctly, and then if you're one of my Patreons, you'll get that box for free. So I will talk to you guys later.